No human mission has ever gone this far. But now, we might actually try.
Starship changes the equation. Fully reusable. Massive payload capacity.
Yeah, but Uranus isn't Mars.
It's nearly 3 billion kilometers away. Even at extreme speeds, this takes years.
So this isn't a mission. It's a commitment.
And we barely understand what's waiting there. Temperatures drop below minus 220 degrees Celsius. It rotates on its side, unlike anything else.
So we're sending a ship into a frozen, sideways planet.
We're sending it to understand the outer solar system, because what we learn there affects everything.
This better be worth it. Okay, why Uranus? Why not Mars or Europa?
Because Uranus is one of the least explored planets we have. We've only visited it once, back in 1986.
Wait, that's it? Just one flyby?
And a quick one. Uranus is an ice giant. Not like Jupiter or Saturn. It's made of water, ammonia, and methane ice.
So it's basically a frozen chemical soup?
A very important one. Ice giants might explain how planets actually form, because most planets in the universe are similar to Uranus.
So we don't understand most planets?
Exactly. And Uranus has one of the strangest magnetic fields ever recorded. It's tilted and completely off-center.
So even its physics is weird?
Which means we're missing something fundamental. Understanding it could unlock new atmospheric science and improve the models we use here on Earth. That's why missions like this cost billions.
Billions? For one planet?
For knowledge that applies everywhere. Uranus isn't just a destination, it's a missing piece.
Okay, that actually sounds important. Okay, so why couldn't we do this before?
Because everything before had limits. Payload capacity was too small, and fuel requirements were massive. Most rockets are single-use.
So we've been throwing away rockets?
Every time. Starship is fully reusable, and it can carry over 100 tons to space.
That's basically a moving warehouse.
A very expensive one. But the real breakthrough is refueling in space. Fuel can be transferred while in orbit, allowing missions to go much farther.
So it doesn't need to carry everything from Earth?
Exactly. This reduces mission costs dramatically, from tens of billions to potentially a fraction.
So now we can actually afford missions like this?
For the first time, yes. Multiple launches can build one mission, piece by piece, in orbit.
That's actually insane.
It's not insane, it's scalable.
So this isn't just one mission?
This is a system for the entire solar system.
Okay, how do you actually get to Uranus?
First, you launch into Earth orbit. Then you refuel, multiple times.
So we're basically building the mission in space?
Exactly. Then comes the hardest part, interplanetary travel. This journey could take 10 to 15 years.
That's not a mission. That's a lifetime.
To make it faster, we use gravity assists. You swing past planets, like Jupiter, to gain speed.
So, space slingshot.
That's actually accurate. After that, it's years of silence. Signals can take hours to reach Earth.
So if something goes wrong?
You won't know immediately, and you can't fix it.
That sounds risky.
It is. Then finally, you reach Uranus and attempt orbital insertion. One mistake, and the mission fails.
No pressure then.
Probes could be deployed into the atmosphere, collecting data we've never seen before.
So after all that, we finally learned something new.
We learn everything if the mission succeeds.
And if it doesn't? Okay, what's the worst case scenario?
The mission never arrives. One system failure and it's lost. At that distance, there's no recovery.
So if something breaks, it's just gone?
Completely. Then there's radiation. Deep space radiation can damage onboard systems.
So space itself is trying to break the ship?
In a way, yes. Fuel margins are also critical. A small miscalculation can miss the planet entirely.
You miss once, and that's it?
There's no second attempt. And then there's cost. Missions like this can cost billions.
So if it fails, that money is gone?
Completely. And future missions become harder to justify.
So failure doesn't just end one mission.
It can slow down an entire field.
That's a lot of pressure.
That's why missions like this are rare, and why success matters.
So everything depends on this working. So after all that risk, why do it?
Because missions like this redefine what's possible. Every major leap in space started with something like this. Risky, expensive, and uncertain.
And most people probably said it wasn't worth it.
They always do. But Uranus isn't just another mission. It's a gateway to the outer solar system and beyond.
So this isn't about one planet.
It's about expanding human reach. This mission could unlock new science, new technology, and industries worth trillions in the future.
So this isn't just space exploration.
It's economic expansion on a planetary scale, and eventually, beyond it.
That's actually insane.
No, it's inevitable. If we can reach Uranus, we can reach anything.
And closer than we think. Like, subscribe, and share.